4 degrees. I don't know how wide the band is, but let's say it has a band of plus or minus 2 degrees. You have it on AC, hit 76, AC goes on. Hit 72, AC goes off. So, and on and off. There's the tuning parameters, if you have a tuning parameter, is how wide the band is going to be. And of course, what's the disadvantage? You're not getting your nice 74, you're getting between 72 and 76, right? Now, it's interesting though, you can convert such a system into a temperature control system, and we have done that. Bree and Megan and Hunter, and who else am I forgetting? Is he in this class? I bet there's not in this class. Those who are working in Dr. Pratap's lab. Temperature control of a digester, where you have a heating tape. And ideally, you would be able to control the current through the heating tape, but very primitively, you can only turn it on and off. How can you change heating tape on and off? And you can do that with the heating tape. You cannot do that with the AC. How you can change an on and off performance into something that is PI or PID. The trick that we did, it was actually Megaforce, sorry, not IPD, it was a Megaforce project when we had the Megaforce. So you can change an on-off thing into a continual control if you have a fairly short period of time and you consider as your manipulated input the fraction of the period that it's on. Okay? So your output is, let's say you have 60 seconds for the heating tape. What you're manipulating is how long of those 60 seconds the heating tape will stay on. Because electricity you can turn on and off instantaneously. Okay? If it's on 40 seconds, is 40 out of 60 seconds is one value, 35. Is that how it works? So you have, your U is fractions of the 60 seconds that the heating tape is on. The heating tape is on the first, let's say 40 seconds of the second 20, or the first 35 of the second 25. And then you can have PI control on that fraction. And because the 1 minute interval is small, the fluctuations in temperature from the set point are negligible. So you can have very good set point control and disturbance rejection by changing an on-off situation to a continuous signal situation with that trick. But you couldn't do that in your house air conditioning because the air handlers and this need some time to go on, etc. It wouldn't be good for the device to turn it on and off all the time. Okay? Finally, come on, stop 10 minutes, guys. There is another method that I have seen in a book, the Seaborg, etc. book. They call it the trial and error method. It's a method I could have taught to you the first day of class. And it's a method I would never even use, period, ever. But remember how we talked about the Ziegler-Nichols method, that ostensibly you could try to find KU and PU experimentally by setting your actual system on P control and continually increasing KC magnitude, changing the set point up and down until you reach the verge of oscillations. The verge of instability where the oscillations don't blow up and don't die out. But remember, I told you should really never do this in practice because it takes forever to judge if the oscillations are staying, dying out slowly, or blowing up slowly. And during that time, your system would be behaving horribly, and you're also playing with danger. So instead, do the step changes to your GU and use program like the class program with body stability criterion to find K and D. Well, the trial and error method first finds KU experimentally, like we just said. But instead of calculating tau I and tau D from that KU, sets KC to half of KU, same thing as Ziegler-Nichols for just proportional control, and then starts integral action, starting with a high tau I, having Kc at Ku over 2, until again you bring your system to the verge of instability. So you have to go a second long period with terrible system performance and setup. And then you set tau I as 3 times the tau I that would bring you to the verge of instability. And if you have derivative action, guess what? You do it one more time. Now you start increasing derivative action until you bring your system to the verge of instability. I just mentioned it because it's in the book. Don't ever think of implementing. All right. Last day of class. I still have 7 minutes. Questions? Okay, so I'll talk about the exam the remaining 7 minutes.
Yeah.
Okay.
All right. So, for the exam, you are allowed. Oh, can someone remind? Well,
10.
it is.
We're between 10 and 15.
No, I gave you 8 pages last time.
We're selling on 10.
So 8 pages of handwritten notes. That means 8 pages front and back. Sorry, 8.
No!
No. 8 pages. That means 8 pieces of paper one side, or 4 pieces of paper 2 sides. No, guys. That's plenty. Come on. You have 8 pages. That's plenty. Material for the exam starts from experimentally getting first order plus time delay models on until the end of class. Okay? I guess, can you easily print a page?
No.
All right, then because I may need expanded dictionary, okay, I will give you the dictionary. So I'll provide the dictionary if it is needed. Only if it is needed, I'll provide the dictionary. Okay? Yeah.
Do you have computer heart?
That's then the next thing I'm going to do. I still haven't made the exam, but even though, mostly, to be honest, for me, it's a lot shorter to grade pen and paper exam than computer exam. I might give you printouts, study the spring 15 exam. That's the only exam I have given that was not computer. I tell you, I tell you to write on paper the transfer function which you would put in the program. And I'm telling you, assume that the transfer function is this printout and proceed. So if it's not computer, I will do it in that fashion. But I haven't yet made up the exam. So I'll make it sometime tomorrow. I will check your announcements. At this point, please have a computer ready. If I can manage, of course, in terms of studying, it means one part type of problem cannot be if it's not a computer exam, and that is the getting first order plus time delay by using solver. Remember the equals if conditional T, like a homework. So that would be definitely motivation for me to have computer exam. So do study that. I probably will not finish the exam until the evening tomorrow. So
You'll send
I assume at this point that it's computer exam, but check your email. If I have succeeded by tomorrow evening late, probably, to have made exam which doesn't have a computer. Besides, I want you to study that stuff anyway. So, okay, so assume computer exam, but check your email. Any other questions about the exam?
How many questions is it going to be around?
I haven't even made it.
So,
You have so many examples.
give me a number.
All the mega cosecond exams.
Yep.
Last year's third exam was a good exam.